Hello everyone, welcome back to my channel. I'm Sucharita B, studying computer science in Sri Venkateshwara College of Engineering. Today I will be talking about optical fibers. So I will be talking about types of optical fibers. Consider an optical fiber. As you can see in the image, there is something called cladding. Cladding is an outer optical material surrounding the core. So in any optical fiber, the refractive index of the cladding is uniform, but the refractive index of the core material may either remain constant or can vary in any particular way. So the curve which represents this variation of the refractive index with respect to the radial distance from the axis of the fiber is called a refractive index profile. And refractive index profile can be shown in the following manner. So there are three types of optical fibers. First one, single mode fiber. The second one, step index multimode fiber. And the third one, graded index multimode fiber. And we will be talking about all the three types of fibers today. Before beginning with that, let us know the main elements of fiber optics. The first one is core. It is the central tube of very thin size made of optically transparent dielectric medium. It carries the light transmitter to the receiver. Second one is cladding, which we've already talked about. It is an outer optical material surrounding the core. It has a refractive index lower than the core, and the cladding helps to keep the light within the core throughout the phenomena of total internal reflection. Next one is buffer coating. It is a plastic coating that protects the fiber made of silicon rubber. You can see from the image, it is easy to understand. You can see the core, cladding, and the plastic jacket. Let us start with the single mode fiber. So in single mode fiber, only one type of ray of light can propagate through the fiber. You can see in the animation which is above, it allows only one type of ray to propagate. A single mode fiber has a core material of uniform refractive index value, and cladding also has a material of a uniform index but of lesser value. So this results in a sudden increase in the value of the refractive index from cladding to the core, and refractive index profile takes the shape of a step. I will be showing the refractive index in the next slide. Before that, diameter value of the core will be about 8 to 10 micrometer, and the external diameter of the cladding is 60 to 70 micrometer. So what happens is, in single mode fiber, it shrinks the core down so small that the light can only travel in one ray or mode. So hence the name. And single mode the fiber has a core diameter of 8 to 10 microns. So here you can see the refractive index profile taking the shape of the step. Geometry is also being shown, and these are the most extensively used ones, and they constitute 80% of all the fibers that are manufactured in the world today. They need lasers as the source of light. Though less expensive, it is very difficult to splice them. Splice in the sense it is very difficult to join two or more fiber optic cables together. And application they are used in submarine cable system. So talking about advantage, there is no dispersion, that is, there is no loss of quality of the electronic signal while traveling through the fiber, and submarine cables can carry massive amounts of data, providing a significant increase in the bandwidth capacity compared to older communication technologies. And submarine cable systems to a network of cables laid on the ocean and ocean floor that enables the transmission of various forms of communication such as telegraph messages, calls, data, and internet services. They're used for long distance communication. Disadvantages is it requires tighter tolerances and is of higher cost. The next one is a step index multimode fiber. So a step index multimode fiber is very much similar to the single mode fiber, except that its core is of larger diameter. A typical fiber has a core diameter 50 to 200 micrometer and a cladding about 100 to 250 micrometer. So its refractive index profile is also similar to that of a single mode fiber, but with a larger plane region for the core. And due to the larger core diameter, it can transmit a number of modes of wave propagation. And the step index multimode fiber can accept either a laser or an LED as a source of light. It is the least expensive of all, and its typical application is in data links, which has lower bandwidth requirements. And it is mainly used for lighting, consumer audio, and video links. You can see in the image below, you have the refractive index profile as mentioned. It has a larger region for the core, and the geometry is also shown. Disadvantages is as only one light ray propagates through the fiber at a time, it somewhat leads to a drawback in terms of its capacity to carry information signal. Also, due to the smaller diameter of the core, coupling the light inside it somewhat difficult. The next one is graded index multimode fiber. It is also called as GRIM. The refractive index of the core decreases in the radially outward direction from the axis of the fiber and becomes equal to that of the cladding at the interface, but the refractive index of the cladding remains uniform. So in this type of optical fiber, the refractive index is higher at the axis of the core and then it decreases gradually towards the core cladding interface. That is to say that graded index fiber refractive index of that gradually decreases from its center and eventually decreases to the same value as the cladding at the core edge. So laser or LED is a source of light. It is the expensive of all. It is used in telephone trunk between central offices. So it is made with a range of materials in the core which are chosen to minimize model dispersion caused by different path lengths of different modes being transmitted down the fiber. Generally, they are used in comparatively less bandwidth requirements and short haul applications like local area networks, which runs at 1 Gbps, otherwise less. And they use variations in the composition of the glass in the core to compensate for the different path lengths of the modes. It offers hundreds of times more bandwidth than step index fiber, up to about 4 gigahertz per kilometer maybe. And graded index multimode fiber is primarily used for LANs, fiber to the desk, CCTV, and other security systems also. So this is its refractive index profile and the geometry. Disadvantages: it has less light coupling efficiency. It is costly as compared with step index fiber. The uses of fiber optics: it can be used in computer broadcasting and networking, which is a generic example. They are used on the internet, television cable. Fiber optics are widely used in military activities. They're also used in medical purposes like for precise illumination. They can also be used in underwater environments as they don't require to be replaced frequently. So the difference between single mode and multimode fibers. In single mode fibers, only one path of propagation. In multimode fibers, more than one path is available. Here, no dispersion effect, their higher dispersion. Here, core diameter is very small, their core diameter is higher. Single mode fibers have higher bandwidth, multimode fibers have lower bandwidth. Here, they are used for long haul communication, they are used for short distance communication. In single mode fibers, fabrication is difficult and costly. In multimode fibers, fabrication is less difficult and not costly. And thank you. I hope you have understood all the three types of optical fibers.